Welcome. Today we will see few interesting sensors that we have fabricated in our facility, as also some few commercially available sensors to understand what all innovative methods we have used or people are using to come up with sensors of extreme precision or of very cheap cost. Both spectrums we will see. So, to start off, here we have a series of electrodes. So, let us just see that now. We have a series of electrodes that have been formed on a glass substrate. Here you can see a series of electrodes, exactly 30 number of electrodes that we have fabricated here in our facility on glass substrate. So, the material of the electrode, is gold. Okay. So, the contact pads are visible below. Bottom, if you see these vertical structures, so those are the contacts for sensing the electrode, and the material is gold and the substrate is glass. Now that you have covered so much portions in the fabrication course, you would know very well how this would have been fabricated. So, what we will do now is we will take a glass substrate, clean the glass substrate, then what do? Then we will deposit gold of some thickness, actually not gold, if you remember correctly, we should deposit chrome gold, some thickness of chrome, and then on top of it a defined thickness of gold. This is done so that the gold can attach or adhere or stick onto the glass substrate properly. So, the gold is deposited thoroughly. Okay. Then we have to pattern the electrodes, right. So, we have to make a mask first, mask plate will be made. So, the mask plate will be we will coat a photosensitive material PR on top of the gold that was deposited, expose this photosensitive material with the masks that we make for these electrodes, develop the photosensitive material, correct. I think these processes you would have learned, develop the photosensitive material. Then what do? Then we will have to etch out the gold that is not required from rest of the places. Only where the electrode is there only we need the gold, and in all other places we will etch out the gold using gold etchant like potassium iodide and chrome etchant also. So, we will remove the chrome and the gold. Then finally, we will end up with this beautiful structure. So, in this structure, if you see, you can see small square like patterns one by one, those are the electrodes. So, within them actually we have made 10 micron spacing electrodes. So, there is like 20 micron width electrodes and 10 micron spacing between them. So, those electrodes we have made as IDE structures in this, and then in one column there are 10 electrodes and there are contact pads for each of them. Like that we have 3 columns. So, total 10 into 3 we have 30 electrodes deposited on this 3-inch glass substrate. So, this is a 3-inch glass substrate. Okay. Now, you will know, as I have told, it is 10 micron 20 micron features, you might not be able to, you will not be able to actually see this here, you can only appreciate the overall structure of the electrode. Now, let us actually look at it in the microscope. I will just put it on the metallurgical microscope which we have covered before and see how the electrode structures are looking. So, I will just load it onto the microscope. So, before we see anything on the microscope, first we should start with the lowest magnification to know the features properly. Okay. So, let us look at the screen now. So, I have kept, okay, before looking at the screen, So, the sample is loaded. I have kept the 5x magnification microscope, focused it on a electrode structure. Now, let us look at the screen. So, you can see in the screen, this is at 5x magnification. So, this is the electrode, the square shape that you had seen, where I had told there are interdigitated electrode structures. So, these are the electrodes at 5x magnification. Now, we will go zoom in, I will go to 10x magnification. So, we have to fine tune it again. Okay. So, I am adjusting the focusing. So, now the focus is adjusted. So, now you can see it is at 10x magnification, you can nicely see the electrode pattern. I will just move the sample around so that you can appreciate the features. Okay. So, these are the electrode structures. If you want to see in much more detail, you can go to the next level of magnification, which is 20x. So, this is 20x magnification. Okay. At 20x magnification, you can see the exact finger like pattern of the electrodes, correct? How the interdigitated structure, which we have covered in the course, how they are structured. See, one pattern of electrodes are coming from top, one set of electrodes are coming from bottom, but they are not in contact, they are like this, they are not in contact, but once something that has to be sensed, it kept on top of this electrode structure, the contact will be made, correct? And then we will be able to sense it with the contact pads which will be there. So, like this we have made 30 electrodes on this single 3-inch glass substrate. So, we have made so many electrodes because the gold deposition process is itself is quite an expensive process. So, if you want to do short loop experiments with just the electrodes and do not want to integrate the electrode with some microfluidic channel or heater or anything, and you want to just try out how the electrode will work, you need to have as many electrodes as possible in smallest area possible. So, that is what we have done because we wanted to do some preliminary experiments with this electrode structure. So, we have made 30 electrodes on the glass substrate. So, this is one interesting microfabricated component that we wanted to show today. So, now next let us just see. Now, let us see another interesting sensor, microfluidic chip in fact. I hope it is visible to you now. Okay. So, this is a microfluidic chip. This is not something that we have fabricated, it is made by a company called Applied Biophysics, but we wanted to show it to you because this is a very interesting microfluidic chip which is actually fabricated at very low cost. It is made of plastic and it is flexible. See, I am flexing it, nothing happens to it. There we saw the sensor made of glass. So, this is made of plastic, everything is made of plastic actually. So, the top surface that you are seeing is also made of plastic and the microfluidic channel is on this top surface. And the electrodes which you usually see are screen printed by a method called screen printing. They are screen printed on the bottom plastic surface. I will just tilt it. So, when I tilt it, you can see the screen printed electrodes. You can see the screen printed electrodes here. See. So, if you observe, these are not very micro dimensions. The electrodes are actually even 1 mm thick electrodes. If you see, these are also again interdigitated structures. If you see, this is the first electrode and these are sub interdigitated structures. This is from applied biophysics. So, these are like 1 mm features. So, this can be done with less expensive processes. So, they have used something called screen printing to print the electrode structure, and the electrode is formed, and then they make the microfluidic channel. So, these are the inlet and outlet ports, and there are some sample input ports, and there is a microfluidic channel running inside. You may not be able to see it very clearly, but there is a microfluidic channel running inside. So, you will load your sample like this, and the sensor below will sense the changes. The idea is they have tried to sell it as a product. So, when we are making it, we should look at how these companies are making these chips, because when we are doing research, we should, as I have explained before, we should also look at how it can be made translational, how you can actually make it sell, not necessarily for monetary purposes. Selling in the sense we should be able to make impact to the society with our research. So, we should be able to reach to the masses or to the clinics or to the doctors, and if possible make sure that at least on a weekly basis or a monthly basis they are able to use our research outcomes to help patients or help people in general. So, to do such things you need to have cost effective ways of fabricating stuff. So, this is one way. So, this is plastic. Through plastic they have made this, they have bonded plastic to plastic. So, those are all very interesting concepts, and how they have made this very cheap. This is a use and throw, it is very light, it is hardly I think 10 grams. So, they have made this use and throw microfluidic chip with not very fine electrodes, just macro level coarse electrodes, but so long as it senses differences between your control experiments and you are able to come to a diagnosis, it does not matter whether you are having 10 micron electrodes or 1 mm electrodes, but you have to be very careful about what is your actual application. If your application demands that you need to have a 10 micron electrode, then we do not have any other option but to go ahead with the previous sensor that we showed where we had 10 micron electrodes. But if your application involves macro sensing, then you can go ahead with such electrodes, such big electrodes. So, there is always a trade off involved between cost, design constraints, material used, like you want gold or platinum, or you want to use PDMS or plastic or glass. So, you should look at it in a very holistic manner and see what is your exact application and where you can compromise and where you cannot. In places where you cannot compromise with the design, you should not worry about the cost, because functionality is a core or the heart of your design. Unless it does not function with good accuracy, specificity, selectivity and all, even if you make it cost effective, it is not useful. First functionality has to be met with good faithfulness, then you look at reducing cost and size and other form factors. So, this one chip we wanted to show you today. Now, just a quick thing. So, in a previous session we have seen PDMS molding, right? We made PDMS and molded it using silicon master and all. That time we have told that the PDMS will be bonded to glass, correct? So, we have a PDMS membrane which does not actually have micro channels, it has only holes. You can see the punched holes here which are being punched using a biopsy punch. So, this is a thick, it is almost I think 1.5 centimeter, 15 mm thick PDMS membrane, see top membrane, it has been bonded onto the glass slide, the standard glass slide which are used in biology experiments. They have been bonded onto the glass slide, and even if you try to pull it out, they will not come out, because they are chemically bonded, or like they are at the atomic level, at a molecular level they are bonded to the glass. So, this is done using method called oxygen plasma. So, this way you can bond PDMS to glass. So, this I wanted to show you, because that time we had not shown you how we have bonded to glass. So, this PDMS membrane has been bonded to glass using oxygen plasma. You can see one more chip, same design is there. Okay. Now, we saw these things, we saw electrodes, fine electrodes, coarse electrodes, different materials, glass, plastic, PDMS glass bonding and all. Now, let us go back to the basics. By going back to basics, what I mean is, we have one very unique sensor that we have made. If you can see, so this sensor is made for sensing biological interaction between molecules of very small size, like under 10 microns. Okay? And what you see is not what it is all about. So, this sensor has been made with multiple processes. So, you might have known that there is something called photolithography, correct? We made the electrode patterns before using photolithography, but photolithography has its limitations. In photolithography, we use UV light to expose patterns, correct? But UV light is limited with its wavelength. Because of that, there is a finite limit to which it can go to, maybe around 1 micron or maybe some nanometers. It can, like 800, 900 nanometers, it may be able to go as features. But what happens if you want like 200 nanometer or 0.2 micrometer features? For that, you have to use something called e-beam lithography. So, this sensor has electrodes that have been fabricated using e-beam lithography at the center, at different parts within, which you will not be able to see, and then on top of the electrode we have made coarser structures, bigger structures which are in the micron scale, using photolithography. So, we have used photolithography, okay, on the outside features and e-beam lithography to make the exact sensors at the inside. So, this is how this sensor has been made, and the contact pads are here. Because in microscope, if you see, you might not be able to see it very clearly. So, I am not showing exactly in microscope in this, but this is the overall idea about this. So, you can see that how we can engineer such devices. So, we have used multiple processes, e-beam lithography, photolithography, gold deposition, etc. on this silicon wafer, oxidized silicon wafer, to make this extremely versatile chip that can be used to measure interactions of biological molecules at sub 10 micron level. So, that is, so again what this is, again coming back to what I told just now. Look at what is your design constraint, what do you want to actually sense? You are making fabricated sensors. What is it that you want to actually sense? What is its dimensions? What is the electrode that you need to make so that it is sensitive to such interactions? Then you fix your electrodes, and depending on that, after you fix that, that will be a fixed criterion. Then you change other things to reduce your cost or material consumption. So, this is how you should approach your design. So, this is another sensor which we wanted to show. So, we have seen a series of 30 electrodes on glass substrate. We have seen very interesting cheap microfluidic chip that is made using plastic. We also saw how a PDMS membrane was bonded to glass. Now, let us go back to the PDMS membrane that we have molded in our previous session. The channels were made. That time we had told you that this PDMS membrane will be bonded onto a glass substrate with electrodes deposited on it. So, we have actually done that. So, we wanted to show that to you. So, we have the glass substrate below, the electrodes are there, you can see it, right. The golden color electrodes are there, electrodes are below, and to that glass substrate with the electrodes we have bonded the nicely cut PDMS channel. So, channels are there visible here, hope you can see, may not be able to see, but you know that you have seen this before. So, there are channels here. So, the PDMS is bonded onto the glass with the electrodes. So, if you see from side, you can see that this PDMS layer is bonded onto the glass. It is bonded using oxygen plasma. With this process, this device is actually ready to be tested, fully ready. We have punched holes. If you see here, we have punched holes for the inlet outlet of the microfluidics and also for loading reagents. Holes are punched, the electrodes are in place. So, the device is complete. This is how you complete the fabrication of a device. Okay. So, these are few devices that we wanted to show. If time permits, we will be showing you more devices in the duration of this course. Otherwise, you should have an idea that this is how device fabrication is done and what are the different constraints that you should take care, design constraints cost constraints, time constraints, so that you are able to make your sensor in the most robust manner and also package it using methods like 3D printing, so that it can reach the end user and have a societal impact. Thank you.